Engine is a cloud-based geospatial analysis platform developed by Google for processing and analyzing the large-scale satellite and geospatial dataset. So it combines the multi-petabyte of satellite archives, high-performance cloud computing, and geospatial analysis tools. And here we are using normally JavaScript or Python APIs, but for Google Earth Engine, I am using the JavaScript. And it's very basic. No need to take much thing about this JavaScript. It's very easy. And it is ready to use, fast processing. As we know, we can see here. Okay, we will go. So first of all, for GE, we have to create an account. So you can, if you have the account, then you can work with me. Otherwise, you can see how I am doing. You can have the account later on, and you can analyze the data. I will provide the code whatever I prepared for today. I'll discuss some of the indices that I'll provide the code also with Dr. Sankalp. He can distribute to all. And so first you create the account, then some of the questionnaire you have to answer. Then you can start with the code editing part. Then this is the typical user interface of a code editor. You can see here. So let us go directly to the. Wait. So you can see here. It is visible now.
Yes, sir. Yes, sir.
Okay, so you can see here, this is the typical user interface of a Google Earth Engine where we are analyzing the data. Here you can see scripts is there. So here in scripts, you can store your codes or develop your codes. And here docs is there. Docs is for different, E means there is some functions already developed. So you can use that function directly. Okay, here you can see here we have used image collection like that. All others also there. You can go ask for your application. Then asset is there. Asset here you can store your save files. So you are working in a particular area. Let's say you are working on Bhubaneswar. Okay, so that particular Bhubaneswar area save file you can store here and you can work on that particular area. Similarly, I have developed today for this Brahmaputra river analysis. So I have created a save file. Around 240 kilometers of save file I have created from this Gwalpara to this Tejpur location. This 240 kilometers of length of the river I will analyze today. I will show you. And here, this is the code platform where you can edit your code, write your code. Okay, this is the platform. Then you can save and run. You know, these basic things are there. Then here, inspector, anything problem is there. Let's say some error is there. Then you can inspect here what kinds of error it is and try to solve that error. Then console is there. So console is kind of, you know, console, every coding platform, this console is also there, and task whatever you want to extract. So that can be done here. So let us go to script. I have developed some of the script for different Landsat observation, Landsat 5, 8, and Sentinel. Both 3 optical satellite observation I have developed here. And you can see here, search box is here. Whatever satellite data you want to, let's say you are analyzing satellite, let's say Landsat 8. Okay, so here you can see USGS provides this Landsat 8 collection, 2-tier, 1 TOA reflectance, all these different kinds of observation are there, satellite images are there. Whatever you want to do, you can just click on it and it will show all the description, whatever bands is present in that particular image, then image properties are there. Okay, and use. So here we are directly we can copy this particular collection and that can be called in the code. You understand that this actually if I select this particular image collection, then whatever image is present in that particular observation, it will come to your workplace. So here I have used, let's say, Sentinel 2 data I have used. So we'll go one by one. First, we'll start from NDVI. Okay, NDVI Landsat 5. Okay, so here I have already incorporated my region of interest. So let's say I'm showing you. Just delete it. Okay, now we can. Here directly, I have already uploaded the save file. Here we can directly call it. Okay, so it is stored in form of variable table. So this table I have to call here, but I have already used the ROI. Okay, here I have already used the ROI. So I need to change the variable as ROI, region of interest. ROI. Okay, now let's save the code. Okay, now let us discuss what is there inside the code. So first here you want to download the data. As you know, this Landsat 5 image, you can we have already seen that Landsat 5 image. They have I want to collect the data from 1984 to 2012. Okay, so I called all the years here. 1984, 85, 86 up to 2012. All the years. Let's see if all the years are there or not. And if any years is missing, also it will show it. It will show in the taskbar. It will show in the taskbar that a particular year is not there. Console here we can see that particular year is not there. Okay. And if all the images are there also, it will show the result. Then for each year, I am calling the function for year. Then the filter, I am using the filter. I want only the images which are the post-monsoonal images, means after October, November, December. Okay, because why I am doing this? This is important. Whenever you are analyzing some data, you have to identify in which period it will give you the best result. Okay, the all type of activity in a river is after the monsoon. Means monsoon will come and it will disturb the river. And when monsoon will recede, means when the flood is receding, then that is the time all kind of activity is happening inside the river. The river is very active after the monsoon, because monsoon it will behave like a single channel system. You don't know what is going to happen in the bottom of the water. But whenever flood recede, the water level will decrease. Then all the energy on the water will be decreasing. The turbulence dissipation will be there. Dissipation, why I am talking about dissipation? Because all the sediment load comes with the water. It will try to settle during the low energy period. So all the activity inside the river will be high in the post-monsoonal season. So here, that is I am observing what kind of changes is happening inside the river. That's why I have used the post-monsoonal season. Similarly, if something happens in the pre-monsoon also, you will target only pre-monsoon. If you want to have the only monsoonal changes, then you can target in the monsoonal. But in the monsoonal part, there is lots of cloud cover there. During those cloud cover, you have to some cloud analysis. You have to do this cloud cover analysis. You have to do, that is different topic. So here in river health analysis, we are normally focusing on the post-monsoonal season. If some kind of comparison is there, then we are analyzing pre-monsoon as well as post-monsoonal season. Okay. So as you know, image collection already, this is directly called from the satellite image repository. Then filter data, I have as for the start data and end data, filter bound is there. Filter data, then filter bound as for the ROI. Then whatever result it will give as for the ROI only, reason of interest only. Otherwise, it will take all the maps. We don't require. Only we require whatever reason is of our interest. Then map function is there. All this already developed function. No need to develop. Then I know, as you know, here. Okay, so here you can see there are different kinds of indices what is used for the river health monitoring. One is NDWI, MNDWI, NDVI. NDWI, normalized difference water index. Modified normalized difference water index. NDVI is normalized difference vegetation index. Similarly, NDBI is there, NDTI is there for turbidity. Then FAI is there for algae analysis. Then NDSI is also there for soil index. So we'll discuss one by one. Let us first discuss NDVI. NDVI is nothing but NIR minus rate divided by NIR plus rate. So NIR, near infrared, and red band, normal red band. So here we have to call this variable NIR, variable rate. Then directly we can use this variable NDVI. NDVI, simple NIR subtract rate divided by NIR R rate. Okay, and rename this variable at capital NDVI. Okay, next we can use this copy properties, means this all the result will be copied. Then the name will be restored. Okay, so create median composite. Why I am using this median composite? Because whenever I am analyzing the 3-month period time, so there are some temporal resolution are there. Maybe 8-10 images are there. Okay, so that 8-10 images, it will try to create a median pixel. So all the 8 images, it will use all the 8 images and try to create a median pixel at a particular location. So all the pixel is in the form of median. Okay, so it gives a good result. Maybe some pixel having let's say for 2-3 pixel 2-3 observation, it has some error. It has some error. Null data may be there. That may be happen. So it will eradicate those and it will collect another 4-5. So if the number of images is more, then this median value will store only the best value, and it will consider all the value, and it will calculate the median data, and it will store in that particular pixel. So here, then we'll click this to ROI as for our region of interest. This then as for this is the visualization. All this color palette. This is nothing but the color palette. This visualization, and here we can display the layer. I will display this is used to display these things in our working zone. Then we can export it to our Google Drive. Okay, simple export function is there. Export.image.to drive. So wherever we want to store, it will store. So let's say if I press run. Then see, it is working here. You can see here in the layer, it is working. Okay, now you can see the image is coming. Yes. So here you can see this green part of the vegetation part, and this is changing as I have called for lots of year. Okay, so that can be stored here, each and every this 1985, 1984, wherever data is there, proper data is there, the result comes and it is stored in this particular here. So we can run it and store it in our Google Drive, and we can work whatever data we want to analyze. Okay, so I hope this is clear to all. So if you have any doubt, you can ask me so that I can go to the next indices. So anyone have any doubt? Otherwise,
Sir, I think we can take it at the last.
Okay. So
that will be better.
Yes. Okay, sir. Then let us go to next. This is for Landsat 5. Similarly, Landsat 8 also is there. So as you know, Landsat 8 is available after 2013. So up to 2025, I collected the data for Landsat 8. And same this kind of things. But here band is different. For different satellite observation, the band is different. So as for the band, I have used the data. Same kind of code is exactly same. Just I have changed the bands. Okay. And this particular image collection line. All other things are similar. And here also same, after saving, you can run the code and it will also give the data. You can see here. Maybe a better resolution data here. So here you can see a better resolution data and better observation we have collected. You can see here. Okay. So next, similarly, I have developed for Sentinel-2 also. Sentinel-2 is why I did this Sentinel-2. Sentinel-2 gives us 10 meter into 10 meter pixels. So the resolution is more finer. So more finer means more means the result will be good. Okay, but we have to do some cloud masking here because the Sentinel data, it is, as you know, the Sentinel data having some cloud interferences there. So I have done some cloud percentage up to 20. I have fixed here. So similarly, same here also band I have used B8, B4, and B8, B4 is NIR and red. Same kind of algorithm I have written here. Then the all other code are same, nothing changed. Okay, so here this visualization colors are there. Then save it, then run. Let's say. Okay, here you can see more detailed result. Whenever you are analyzing at a pixel level, it is a little bit difficult to see here. Whenever you are extracting the image and analyze particular image in a pixel level. Why we are using the pixel level? We have, due to this flood, there is some changes. Whenever we are analyzing or comparing the different year data, we will know that there is some erosion is there, or there may be some more vegetation is there. The density of the vegetation is more. That will allow us to understand the river, how resilient it is. Okay. For example, if I concentrate on this particular location, okay, once more, just concentrate on this particular location. Run again. Okay. So you can see the vegetation part here is changing. Yes or no? Whenever there is a low vegetation, there will be erosion happen. Okay. So it gives us the information that the this density of vegetation also can be divided into different types of vegetation. As I have divided it into 3 different types: moderate, densely vegetated, low vegetated, means low, moderate, like that. 3 types I have divided: low vegetation, moderate vegetation, and dense vegetation. Similarly, as for your data, you can divide it into 4 different parts as per your application. You can see here. Now vegetation is less means water will be eroding that particular location. If vegetation is high on a particular magnitude of a flood, if the vegetation is high also, it is eroding. But in a particular magnitude of flood, it can sustain. Like that, we can analyze if once we have all the data. Okay. Beforehand, we have to download the data, then analyze the data, then all the bands, we have to download all the bands differently, then we have to use that in ArcGIS, then we have to create that particular NDVI image, then clip it. All these things it's already done. Or now we are ahead of 5, maybe 7, 10 steps. Okay. Maybe 10 steps we are ahead. So whenever we are just taking that image and analyzing. So similarly, NDBI, I have developed this for NDWI. NDWI is giving us the water as well as non-water pixel. Water pixel, wherever there is deposition are there. In different flood event, after the flood event, there is a deposition. Deposition happens. Okay, the deposition of sediment. So it will create a kind of in-stream arrangement. In-stream that is called as bar, sandbars. So here in Brahmaputra, lots of sandbars inside the river. Okay, the morphological, it is one of the morphological active river in India. So lots of deposition and erosion is happening, and you may heard that in Assam there is every year there is a kind of flood is happening, and the people are working on they are doing the agriculture on the bank of the river. They got lots of loss, okay, due to this flood. So whenever we are analyzing a particular location, this is vulnerable to erosion. So we can have some solution for that, and that solution is the combination of nature-based as well as engineer. Only we are just trying to apply some engineering solution like gray solution. We are just bank protection work we are doing using the concrete. So this will affect the another location in the downstream of that particular section. So it is not a sustainable solution. So that we are trying to develop a solution which is the combination of engineering solution as well as the nature-based solution. Some bamboo fencing is there. Maybe some of the geobags kind of things are there. We can use a particular section as a combination of bank protection work as well as some vegetation grow. So that with time, whenever the vegetation will grow, it sustains some period. Then the root zone are very strong, and it can sustain higher amount of magnitude also. Then no need to construct the bank, the concrete on the bank. So that kind of solution you can give, but it required a very detailed analysis of a location wherever the erosion is happening. So for that NDWI, we need to analyze the NDWI image. Let's see what kind of NDWI image it is giving us. So here you can see. Okay, you can see here not good result. Now it is giving a good result. So because image is very clear, you can see here this is kind of deposition. Okay, and the channel changes is also happening year by year. This blue line are the channel lines, and this lines this deposition unit, in-stream deposition unit. These are okay. So this is for Landsat 5. Similarly, Landsat 8. Why I collected all the data and stacked it? Because Landsat 5 will give for particular period. Then Landsat will give for some particular period. Similarly, Sentinel gives us a very finer resolution data. So whatever data is required, finer resolution is required if you're particularly concentrating on a section of the river. So here, if Sentinel image is available, then you can analyze those data. And if Sentinel image is not available, then you can go to Landsat. Landsat is 30 meter into 30 meter resolution. Like that, you can select as per your requirement. Okay. So similarly, MNDWI is just like modified normalized water index. So it will give, because MNDWI gives us some more reliable image analysis. Why it is more reliable? There are some whenever there is a flood receding. Okay, some of the land having some water is already just adjacent to the land. So that can be collected by that picture is identified by NDWI. But MNDWI clearly segregate those things. So it is kind of better result as compared to NDWI. Not always, but for this particular analysis, it gives us better results. So you can see here MNDWI for Landsat 5. So as you know, Landsat 5 is not giving us a good result for some year. So here you can see cloud cover is there. That's why it is not giving good results. Okay. So let us go to Landsat 8. So you can see here Landsat 8 gives us good result. Clear visibility of this water path. Okay. Similarly, Sentinel 2 also. Sentinel 2, you can see. So this is Sentinel 2 image, more finer resolution, more clearer image. And we can see also clear the nodal location. So at the controlling point, nodal location is not thing but the controlling points. Here is one of the controlling points. Here is one of the controlling points. And you can see here, this is one of the controlling point. One of the controlling point here. This is the in-stream controlling point. Okay. This is the geographical controlling point. You can see here, nodal points. Here. This is the width of the channel is very narrow. You can see this location, and it is kind of, you just fixing two location and where you just move it. Okay, like that, it will oscillate or not. Like that, you can see, you can observe this particular main channel is oscillating with this with the controlling, with these two controlling points. Okay, if I am considering this particular downstream of the Brahmaputra part. So here at this location, Guwahati location, one controlling point is there, and Gwalpara location, that is one controlling point is there, and this main channel is oscillating in between. Yes or no? So this that can means all the whatever sediment will come. Okay, now the analysis is in this upstream part and the downstream part. So all there is no block. If the blockage is there, that means you might know, you might have seen somewhere, if a blockage is there, so whatever happens, that is observing within this particular system. Okay, whatever is going to happen within this particular section. Similarly, whatever going to happen in this particular section, no propagation of this particular location, whatever happening, or any morphological activities happening in this particular location, that will not propagate the downstream. Okay, so like that, controlling point has also a great role that can be identified using this MNDWI images. Not only MNDWI images, you have to also go to the location whether this is really a controlling location or not. Any multi-channel system is there. So validation is also required, but you have an idea. You have more or less an idea where at the particular location where the river is going to control, or there we can do something so that the downstream or upstream part can be controlled, like that. So these are some of the indices I discussed. I have also shared different indices like NDBI for built-up area. If someone is working on smart city and things, they can use this built-up area index. Then turbidity index is water quality we are working in a particular location. Some of the influence of let's say domestic sewage, or the industrial locations are there. Industrial discharge is directly draining to your river. So there you can observe on a temporal basis how this turbidity index going to affect it. So algae index is also there, algae formation, so that you can identify the possible location of the fish culture, aquaculture. So they are using this FAI. Some NDSI, soil index is there. So whoever is working on this particular detection of sandbar and exposed area, monitoring of riverbank erosion, sediment deposition mapping, they are also using this NDSI. So you can try those things, and you can have a feel for this, how this Google Earth engine going to help you. And not only this is for basically river health, whatever is related to river health, and lots of other things can be done for agricultural part, for environmental part, for forestry, ecological part also we can do. So in my research also I have used some of the ecological application for river health analysis. So